Welcome back to another explainer. Today, we're diving straight into Lecture 28 by Skip Uni. And honestly, we are unpacking one of the absolute most critical concepts in all of programming. We're talking about functions in C++. In this C++ functions tutorial, we're going to explore user-defined functions in C++, taking them all the way from simple, everyday analogies right up to high-level system architecture. By the end of this, you are going to have a rock-solid grasp on function declaration, definition, and calling in C++. So let's get right into it.
Okay, let's dive into this. Here is our roadmap for today. First, the magic of functions. Second, modularity and the main function. Third, the anatomy of a function. Fourth, definition versus calling. Fifth, passing values. And finally, number 6, a missing argument challenge.
Section 1. The magic of functions. Let's start with a massive pain point in programming, which is writing the exact same code over and over again. It's tedious, and it's asking for errors. But what if you could just bundle that repetitive code and reuse it anywhere without rewriting it? Well, that is exactly what functions allow us to do.
To really ground this, the instructor uses this fantastic real-life analogy of making a cup of tea. Think about it. Instead of relearning the steps every single morning and evening, boil the water, add the tea leaves, pour the milk, stir in the sugar, your brain doesn't do that. It just bundles all those individual steps into one conceptual block called making tea. And in C++, we do the exact same thing. A function is simply a block of code that performs a specific task and can be reused literally anywhere. You just take all those individual steps, bundle them up into a function, and instead of rewriting them, you simply call that bundled block whenever the task needs to get done. It's efficient, it's clean, and it's just highly logical.
Section 2. Modularity and the main function. Moving beyond just dodging repetitive work, functions completely change how we design our software by bringing us to a top-down system approach.
The key concept here is modularity. Modularity is basically breaking down a massive, super complex project into smaller, highly manageable tasks that teams can work on in parallel. Think about a huge IT company building an operating system. They don't tackle it as one giant monolith. One team takes the user interface, another handles security, someone else does networking. Functions bring this exact same highly efficient architecture right into your C++ program. You're breaking your big logic into small, modular functions.
Now, you might not realize it, but you've actually been using a function all along. Yep, the main function. As the absolute starting point for the compiler, it's the cornerstone function that kicks off your entire modular application. Whenever you run your program, the system actively hunts for main just to begin execution.
Section 3, Anatomy of a Function. Now, what's really interesting about this next part is how we actually translate these concepts into working C++ syntax.
Every custom function you create has to follow a specific blueprint made up of 3 core puzzle pieces. First up is the return type. This tells the program what kind of data the function is going to hand back when it finishes its job, like an integer or a decimal. Second is the function name. This has to be a unique identifier so the computer knows exactly which function you're calling. And third, we have the parameters. These sit inside the parentheses, like int a or int b, and they act as optional placeholders for the data you want to pass into the function's body to work with.
But wait, what if your function doesn't actually need to hand any data back? Like, what if it's just printing a welcome message to the screen? In that specific scenario, we use a return type called void. And void quite literally means empty. It just tells the compiler, hey, this function is only meant to execute a task, so don't expect it to give you back an integer or a double when it's done.
Section 4, Definition versus calling. Because simply writing the blueprint of a function does absolutely nothing on its own.
Understanding the anatomy is great, but there is a huge difference between building a tool and actually using it. Look at the left side here, the function definition. We declare void function1 and write some code inside it. But if we stop right there, the compiler just ignores it during execution. To actually trigger that code, we have to look at the right side, the function call. Inside our main block, we type function1. Boom. The moment the compiler hits that specific line, the control flow instantly jumps up, executes the internal code of our definition, and then neatly returns right back to main to keep the program running.
Section 5. Passing values to functions. Let's move on to something a bit more dynamic and see how this builds into a practical mathematical example.
Functions become incredibly powerful when we start handing them data to process. Here, we have a simple addition function.
The prototype is int add, int a, int b. That int at the very front means this function promises to return an integer back to us. The name is add, and it takes two parameters, an integer a and an integer b. Its entire reason for existing is to calculate the sum of whatever two numbers we decide to feed it.
So when we are down in our main program and we type add 5, 3, those numbers, 5 and 3, are known as arguments. This triggers a concept known as call by value. Basically, C++ takes that value 5 and copies it directly into the formal parameter a. Then it takes the 3 and copies it into the formal parameter b. Now the function has the exact data it needs to actually do the math.
So, the crucial point is what happens next. The function internally adds 5 and 3 together, gets 8, and because our return type was int, it returns that number 8 right back to the exact spot in the main program where the function was called in the first place. You can then store that 8 in a variable, say a sum variable, and print it right out to the screen. It is a perfect, self-contained data processing loop.
Section 6, Missing Argument Challenge. To wrap up, we've got a tricky homework question designed to test your true grasp of function parameters. And that we've covered the core mechanics, Skip Uni leaves us with this interactive cliffhanger. Here's the scenario. You have a function designed to require two parameters, a and b. But what if you make a mistake and only pass a single argument when you call it? Like, what if you just type add 5? Does the compiler automatically assign that 5 to a? Does it go to b? Or does the whole program just throw an error and crash? I highly encourage you to ponder this, drop your thoughts, or even better, go run it in your IDE. The answer reveals a whole lot about the strict syntax rules of C++. Thanks so much for joining this explainer, and keep exploring the fascinating world of C++ architecture.